Welcome back to EducateTube.com. My name is Sipsky, your host. Today I'm going to prove that if you add 20 mils of 5% acidic acid, which is vinegar, and 1 gram of sodium bicarbonate, which is baking soda, together, when you mix them together, because from the previous video I calculated it to be 290 milliliter of gas, CO2, carbon dioxide, that will be produced in this reaction. So that's my theoretical yield. Okay, based on the calculation, you can check the previous video on quantitative chemistry, and from the calculation, and when I add 20 milliliter of 5% acidic acid and 1 grams of sodium bicarbonate, I should, in theory, have 290 milliliter of carbon dioxide gas. Okay, now I don't have that much equipment, but I did salvage a few things together, and I was able to perform this experiment. All right, it's not a standard type of lab equipment, but you can salvage this at home if you know what you're doing. But the most important thing is that you need to have a few measuring equipment. Okay, so the first thing you need, of course, is a balance. So I have this digital balance, which is accurate to 0.1 grams. All right, you need a balance to measure the mass. You need also a syringe to measure the volume of acidic acid. So I have a 12 milliliter syringe. See there? Okay. And then you have a large test tube. This is a plastic test tube with a this is actually a stopper on top of here, sealed, and there is a tube that runs down into this container here, this plastic container. Now you probably wonder what it is, right? This is basically a displaced volume container. It comes with the large container cylinder, and then you have the other cylinder. Now this is upside down for a reason. Okay, what's going to happen is I'm going to fill this up with water. Okay, and I'm going to fill up this with water. I'm going to turn around like this, and it's going to be both of them are filled with water, except this is upside down. Now when the reaction does occur, let's say I put in the acidic acid, 20 milliliter, and then I'm going to put in the sodium bicarbonate, the baking soda. Now I'm going to put in a tissue, and I'm going to put into a little ball, and attach a string to it. I'm going to lower it down because I don't want the reaction to occur right away. I want it to occur just when I close this stopper. And then once it's lowered down, the reaction will occur. The bubble, sodium bicarbonate, the carbon dioxide will bubble through into this chamber, which is filled with water. The bubble, the gas, will then displace and push the water downwards, and the amount of gas that's inside this container is equal to the gas produced, right? You get this amount of gas. Now, of course, I did not compensate for the water pressure, the water vapor pressure, which I might do that for calculation. You have to count for that whenever you displace gas in water, because there's some water vapor pressure involved in here. Probably minute amount, maybe a few percentage. So if I don't calculate it into this reaction, then we can assume there's going to be some percentage error in here, right? But whatever it is, we're going to hopefully get around 260 to 290 milliliter, at least that much. Okay, there'll be some error involved because, like I said, I didn't account for the water vapor pressure that's going to be displaced in here. But whatever, we should still get at least a 90% yield, I hope. If this reaction, we assume, of course, this is a pure sodium bicarbonate, and we're assuming this is 5% acidic acid, okay, vinegar. So all these assumptions we're going to make, and it did say here 5% acidic acid, but we don't know that for sure. That's based on the manufacturing labeling. And here, I'm pretty sure the baking soda, sodium bicarbonate, is quite pure. Most of them anyway has a 99% purity. So I'm hoping that it's about 99% purity. And based on these two, we probably will, there'll be some error, like maybe no more than 5 to 10% error. So we should still get close to 250 to 290 milliliter maximum of gas, carbon dioxide gas. Alright? Okay, let's get started. I'm going to show you, and we're going to do the experiment. Okay, the first thing I'm going to do is I'm going to take 20 mils of acidic acid. Here's a syringe. Take 20 ml. Oops. Okay, there's 10 ml here. I'm going to put in the test tube. 10 ml inside this test tube. Another 10 ml. Okay. That's 20 ml. There we go. This is a 20 ml acetic acid. 5% acetic acid, which is vinegar. Okay, so 20 ml of vinegar, 5% acetic acid. Right. Next thing I want to do is take 1 gram of sodium bicarbonate. Okay, I don't know if you can see or not. This is a digital scale. Its measurement is accurate to 0.1 grams. So I'm going to put 1 gram into this tissue paper. Now I'm going to set it to 0. We'll press tar. There we go. And I'm going to pour 1 gram into here. I just need a spoon or some kind of spatula to pour in here. Let's do that. Okay, let's take 1 gram of sodium bicarbonate. Oop, that's a little bit too much. That was 2 grams there. Still a little bit too much. That's about right. Okay, this is about 1 gram, 1.0 grams. Okay, if you can see that here. This is about, oops, there we go, 1 grams of sodium bicarbonate. So what I'm going to do is I'm going to bunch them together in a, like this, okay, in a bunch. And what I'm going to do is put this inside the test tube when I'm ready. Okay, so I need a string to tie on top of here, and I'm going to lower it down into this test tube reaction chamber where this acetic acid is, and then it should react. Now I don't want it to happen when, I only want it to happen when I am ready, right? So that's what I'm going to do. Okay, so here's a string attached to the tissue of sodium bicarbonate. We are going to lower into the acetic acid like this when I'm ready. So go in there and react. And then we can monitor the bubble that's produced. Okay, now I'm going to load up the water. Right here. Okay, so here is the water and another container. Water in the container, large container, and another water inside this upside down container. It's filled all the way up. Okay, the water's in here as well, but it's upside down. So I'm going to do, this is where the gas will be displaced inside this container filled with water. What's going to happen is when the gases form, bubble up into here, it will displace the volume and the water will be pressed down, and whatever the volume that's empty with gas would be the volume of that gas inside here. Okay, so here's a tube. Now let's take this sodium bicarbonate string. Okay, we are going to lower it in there. Oh boy, no good. Wait. Oh. tube is coming out again. Hold on. Here we go. Ready, set, go. There, I can see the bubble. I don't know if you can see that there. Get this out of the way. Yeah. See? There's a bubble. You can see that right here. There it is. You see that? You can see that from here. Oh, there's some hole in here. Okay, so that's a problem. There's some hole, so this. Oh man. Okay, I need to repeat this experiment. I need a rubber stopper. Well, it's still bubbling, so I'm gonna leave it for now. Okay, we're gonna leave it. It's still bubbling. I did lose some bubble along the way, but we'll see how much air I have in here. Well, at least it's still bubbling, which is a good sign. Alright, so we're gonna measure the volume later on. See how much volume is displaced once it's finished bubbling out the gas. You can see that. There's the bubble there, right there. So it's still bubbling. You can see, bubbling up. Let's see how much volume it displays, how much gas is produced. Okay, so here we see, let's see. You can see that, there we go. This here, this line is pushed out and the gas is in here, it's carbon dioxide gas. Okay. And draw a line. Represent the gas displaced. Okay. Okay, I have another scale. I'm going to measure the amount of water that is displaced. So let's set this to 0. I'm going to pour the water in according to the marking that I got. Remember, the density of water is 1.0 grams per mil. So for every gram that's shown here is the mils that's produced. There, that's about right. Oh, that's horrible. We only got 74 grams or 74 milliliter of gas displaced. That is a very poor result. I would have to repeat this result again with a better equipment. Okay, if you think about it, let's have a look at the percentage error. Assuming I did everything right, which I didn't, because there's a lot of these gas escaping. I should have used a rubber stopper instead of using this porous type of stopper. It's okay, anyway, let's calculate the percentage error. Okay, let's look at how much error I had. 74 mils of gas was produced. Theoretically, I should have 290%. That means I only achieved 25, I think 25.5, which if you round it, I only allow 2 decimal places, or 2 significant figures accuracy, so we have 26% yield. Not good at all. Gotta repeat this experiment again to see what's wrong with it. We gotta do it at least one more time. It was a good start, but not good enough. Alright, let's do it again, one more time. I did learn from it though. There was a lot of gas escaping, so we need to account for that. Okay, let's add 1 gram for the second time. Okay, we got 1 gram. 1.0 gram. Okay, I modified the tube a little bit so that it curve. So just give it a I put a paper clip and I twirl it so that it kind of curved this tube here. There's a rubber tube, a plastic tube, and it should fit properly. There we go. Good. So it will stay there. Now let's do this again. Okay, so here is the sodium bicarbonate, 1 gram. It's gonna put into the reaction chamber. This is the acetic acid, 5%, or we call it vinegar. Okay, let's put it like that for now. Alright, ready to cap this off. So once it's in, there we go. We're now gonna close it tight. There we go. You can see here the bubble is forming, a lot of it. You see that? Wow. I could feel that the there is some hole. There's something that's escaping from this stopper. It's not a rubber stopper. I should use rubber stopper, but I'm gonna close it to allow it to only go one way. Okay. Oh, there's gas escaping, guys. Need to use a rubber cork. Well, I think it's definitely better, for sure. But I could feel that it's just, what is going on? What is it? I think it's because this thing is closed off, that's why. I might have to do it 3rd time, right? Okay, I think we're done. Alright, now let's measure the volume. Take a marker. Pour the amount of water. Just need a scale. Okay, set to 0. Oops, a little too much here. Yep, that's about right. Okay, a little bit better. I got 136 milliliter. Okay, so let's change this. This is now 136. Okay, so that is how much? Let's see. That's 40 something. Yes, 46.7. So around 47%. So I'm definitely improving. I may have to do one more experiment to make sure I did the experiment properly, but 47%. So accounting for some of these error that I went through, like some of the gas escape, the cork was releasing some gas because what happened is the rubber tubing was squeezed, and so the air moved out of the test tube instead. So let's see if I improve on this 47%. I'm hoping I can get around 90%, but we'll see. Okay, so this is the third attempt. Now the only difference I made is that I sealed it with a wax for my stopper. I don't have a rubber stopper. This is a cork, so it was porous. It was leaking the gas, so I put a wax around it, so seal it more tighter. Okay, so that's the difference. The ending's still the same. I bend it with a paper clip, give it that curve, and we're ready to go. So here is the sodium bicarbonate. There is the 5% acetic acid vinegar. I'm going to just put it like this and slowly, okay, don't do it yet, okay, put the tubing in. Okay, as you can see, the bubble is coming. Everything's looking pretty good. This should be the final one that I'm going to be doing in the experiment. So this is the third trial. Okay, you can see there's a lot of gas produced, but I don't think it's 290 milliliter. Probably definitely less than that. Looks like 150 to me. But anyway, I'm going to mark it and then I'm going to measure it. Right. Okay, so I'm going to pour the water up to here. That will tell me how much volume of gas is produced. Okay, so we only got 124 milliliter. Okay, so we had 124 milliliter, and that'll give me about times 100%. That'll give me about 43% yield. So I did 4 trials, and the two number that keep coming up, and that's consistent, and even after I make sure there's no leak. I'm sure there's some leakage, but even that, we're talking about between 43 to 45% yield. Not very good, but got to figure out why that's the case. Anyway, that's what I did get. I was supposed to get 290 milliliter, but I ended up getting 125, 126 milliliter. 124 is this one here. So it's consistent. So 124 to 126 milliliter, and that gave me between 43 to 45% yield. Interesting. We definitely have to repeat this experiment again, but I think this is it. This is the result that I got. Around 125 milliliter is the gas produced. The temperature of this experiment is 23.1 Celsius. Okay, so since it's gas experiment, we have to make sure we know the temperature. So it's around 23.1.0 now. Alright.